Welcome to Power Players by Origis, critical thinking to deliver the promise of clean energy. This program brings you leading voices in solar and energy storage and sectors impacting renewables, exploring challenges and solutions for industry growth, the true cost of operating and maintaining power plants, and system asset management considerations. My name is Josh Corbett. I welcome you to this episode hosted by Michael Eyman, Managing Director of Origis Services.
Today on Power Players, we have Alex Awe. And I think I said that right. I always think of him as gold because of the AU is, of course, gold on the periodic table. Alex is the CTO, CIO, and co-founder at Nextracker. So a real expert. Alex, welcome to Power Players.
I'm excited to chat with you.
Listen, today we're going to talk about the future, but before we do that, and I know that's an area where you have a lot to say, but before we do that, so that everybody understands, give us a little bit about what does Nextracker do? What services, products do you deliver in the marketplace?
Right, yeah, Nextracker, we build utility scale power plants, the support structures for solar panels. They're single axis tracking devices that follow the sun. We are an extremely proven company with the largest bookings. And the most exciting thing is that means that we're also proven. So we have the most product out there that's been weathered under severe weather scenarios. And we are the go-to for quality and reliability. So really excited about that. We've also provided software. We're the first hardware company to be able to commercialize software optimization, and that's really exciting because that's a nice kind of headline, but there's a ton of work that takes place behind the scenes with modeling and different things like that. So very, very proud of those accomplishments.
That sounds perfect. Now everybody knows exactly where you're coming from, and I have to agree. And there's beautiful pictures of your products right behind you. If anybody's wondering, or if they're podcast listeners, they can just miss out. Hey, quick question before we get started. I see you're drinking tea. I'm drinking tea here too. What tea are you drinking today?
Today's Earl Grey. Nothing fancy.
I'm doing basil with lemon and honey. We should have a great episode. All right. Listen, I think, as we were prepping for this, we were talking about the future, and there's some areas that, specifically coming from Nextracker, are hard, right? Solar has sort of evolved from smaller plants in the desert where you had contiguous land space. You could sort of keep them very homogeneous. And today we're in markets that are not necessarily ideal. The land is broken up. It's varied. The weather is much more dynamic. And as the solar becomes more and more a bigger part of the production in these regions, we're having an effect on the demand curve, right? And then how do you sort of design around those things? So rather than ask some big question and have you talk for 40 minutes, let's break it down. Talk to me a little bit about terrain and the complexities of terrain and where you see technology addressing that going forward.
So obviously the perfectly flat land that you don't have to do anything with for prep and landscape management, those have kind of gone away. And so one of the things that we've really worked on is how do we get a product into the ground with the least amount of pre-work, with the least amount of disturbing of the topsoil. We've provided a product called XTR, it's Extreme Terrain Following, where we have the same constant height reveal. And our product is able to do that because we have a balance tracker with a round torque tube, and it's able to follow the contours of land. So from the civil perspective, our partners have to do a lot less work. They don't have to, estimate the size, the height above ground to have a perfectly flat surface. It can really follow the terrain. And at the same time, that also means that if you're following the terrain, you don't have to do earthwork. And we all know that as soon as we remove that top layer, it releases a lot of carbon. It takes a lot of time to resettle. You have to manage irrigation or water off run. All these things come into play and is additional work caused by this cut and fill process. And so the asset manager is required to maintain that topsoil over the life of the project. And so these are all things we're able to avoid if we can just follow terrain of the land.
Yeah, from an operations perspective, I will say trying to reestablish vegetation where your topsoil has been removed and all those nutrients with that vegetation is required, is very, very difficult and takes much longer. And it really exposes these sites to erosion. And like we said before, we're not just on these totally flat sites. We're now in areas like the Southeast where we have a lot of rain and stuff like that. And erosion is a real problem, not just for the site, but for the areas around it. Like, how do you guys see, I mean, you talked about it briefly. Can you expand on that a little bit? Because carbon capture, erosion impacts, your stormwater prevention permits, and things like that are becoming tighter. This is a big issue going forward.
Exactly. Yeah. So we don't have to do any calculations on how many cubic feet of soil that you have to move from one area to another, right? We just go into the building department with our partners and say, every tracker is going to be the exact same height off of the ground, and the penetration of the foundation is going to be the exact same every single time. Because if you have to go higher, obviously you have to go deeper, right? So delivering consistent material, the same product, part numbers out there that goes across the entire array, really simplifies the job, not only during the installation process, but the permitting and getting that all through up front. So it's really being able to adapt to the land brings in so many simplicities because of all the things that we have to fix when we're trying to make a perfectly flat surface. All those go away.
Sounds to me like you're standardizing to the variability, as much as that sounds like an oxymoron.
100%. 100%. And again, I'm mentioning this again, the fact that we have a balanced tracker system and around torque tube actually enables that, makes it a lot easier. Allows us a balanced tracker. It's easier to go with longer rows. A balanced tracker is easy to, at different angles when you're undulating, you have the same type of loads on the system, on the piers and everything, versus something that is wanting to turn over. It's going to react differently at a 45-degree angle, 60-degree angle, or 0.
Yeah. Is this a trend that you see happening globally? Because I'm used to seeing sites completely scraped, remodeled, remapped, new terrain,
I hope so.
Put in. But I mean, I would love to see this happen. Are you seeing this happening?
100%. It's absolutely the first option that we see with our customers, because it gets so much work away from them. They don't have to consider all the things that we just talked about.
Yeah. Well, and the benefits from if you have flowering plants, you've got pollinators, you can improve the production on the surrounding farmlands and
Exactly.
be a good neighbor and a good steward at the same time. So I think that's fantastic. There's another piece, though, it occurs to me, right, which is weather, right? Because it's easy to sort of standardize the variability when there's not a lot in the desert, but in the Southeast, El Nino, La Nina, hurricane season, seasonal variability. This year, they're even saying the Central Atlantic's already at hurricane temperatures, and they're expecting a strong La Nina coming the other way. How do you deal with the variability of weather in these regions where year to year, even on a 4 to 5 year cycle, the standard is non-standard?
Yeah. Nextracker, we pride ourselves on being in front, learning more, and pushing the industry. I think, when we first started in the tracker space, closer to 2010 or 2012, with my first iteration of tracker at a different company. The basis of the design was a sloped roof in the building code and a bridge deck. Neither of those represent what we're doing, where we have a fixed object on one side, out all the way out. Now we're a football fields away, and it's twisting on one side and it's rigid on the other side, right? There's nothing in the code books to do that. And so we were seeing a lot of things that happened in real life that weren't talked about in code books. And so we were the first to go out there and say, hey, we got to do wind tunnel testing. We were the first to say, okay, not only wind tunnel testing, it's not allowed to be static. You actually want to represent something that moves in a wind tunnel. And more recently, we built full-scale test systems where it's not just one row, but it's a full block. So we understand what the interior row, how it's affected by the perimeter rows. We purposely change the shape of the tracker when we have different wind scenarios, the stow strategies. And it actually allowed us to reset the industry, because we paired with the wind tunnel company, and they found that their calculations and assumptions were wrong at a scaled size. because it's just so different, right? And so they actually had to come back and redo their standards for wind tunnel testing. And I'll give you a perfect example of this, right? In order for the tunnel to understand the wind pressures, they have these little pitot tubes, right? And they sense the pressure going over the tracker. But to get good data, you need a lot of these. And so that means you have a lot of little tubes that are running around. And so that's essentially like having the equivalent of multiple fire hoses routed all around your full scale tracker system. And that absolutely disturbs the flow of one row to the next row. And so when we did our full scale testing, we went as far as replacing solar panels with pressure sensors. And there'd be 12 pressure sensors on one solar panel. We had them in multiple locations, the leading edge, the side, the back, the middle. And then that load path went all the way through the solar panel, the fasteners, the brackets, the straps, the torque tubes, the bearing housing assemblies, the piers. And we felt a very strong responsibility to understand this and to create a product based on this that better responds to not only just, tracking accuracy, but like you said, severe weather, right? We have assets that are supposed to be out there for 30, 40, 50 years, providing clean energy from the sun. And I want to be able to leave a product and a legacy out there that can meet that time without concerns of reliability or quality.
Well, I'll tell you, a lot of people who listen to this, and a lot of people that know me know I'm an ex-pilot, so we can talk laminar flow and lift and all these things for hours. So, but I'll take my geek and stuff it in a sock and put it to one side and keep this moving.
Well, we'll set up another.
You and I'll have to get together later and talk about this stuff, because I got tons of stuff to talk about on wind tunnel testing and laminar flow across surfaces, particularly when they're staggered in series like this with the even spacing. It creates some interesting problems.
Yeah, the point to really state though is that our product doesn't exist in the code books. And so it's our responsibility to go out there and do this right. And as the code catches up, right? And so, skyscrapers have been there, slope roofs and bridge decks have been around for a long time. It really is our responsibility to continue to push the requirements and standards.
So you mentioned force majeure briefly earlier. What about, wind is one component of big storms, right? You've got massive amounts of rain. We've talked about what happens, having the vegetation there and managing erosion a little bit. I think that one's one that we've talked about on previous episodes as well. And we've also talked on previous episodes about things like hail. Anytime you have, a lot of uplift in the environment and you've got a lot of moisture, you can and a lot of convection, you can see hail. How do you address hail from a technology perspective, from a tracker perspective?
That can be answered in a lot of different ways. We started first with hardware, and then we really put software on top of that as well. And so I want to make sure to touch on both of those. But from a hardware perspective, the balanced platform is really key again, okay? Because when you're balanced, you can respond a lot faster. Your self-powered module is smaller because it doesn't need to power a motor to move as much torque, right? So that means you have a smaller motor. But if you have a smaller motor and you have less torque, you can have a smaller backup battery. The power electronics are much smaller. You don't have to have big, DC inverters and stuff like converters. And so that fundamental is really key. And when you think about it, it's like we have this really cool display in our office. I don't know if you've ever seen it, but it's got two modules on it, call it 45 pounds each, and a 30-pound torque tube. And if you have this system that's sitting here, and then you have these modules and steel and everything on top, as soon as you're not at zero, it wants to twist and turn over. Now multiply that by, a football field, and you've got 15,000 pounds that are wanting to do what you don't want it to do. And you have to build bigger motors, gear sets, linkages, all those things come into play. And you're literally adding complexity to address something that you shouldn't need to address with a balanced system. And so I could literally power our tracker system that's a football length field with my cell phone. Right.
That's one of those things where, people look at these things and they look at the picture behind you and they think, well, that's simple. How hard is that? Simple is only possible when you really understand the details and the complexities.
Yeah.
Right.
And it's like, because you touched on this subject earlier. Hey, what's the trend? Is everybody going to do terrain following? Right.
Yeah.
I was asked once by a writer, and they were like, "Hey, when do you know you had a good idea?" And I said, "I don't, because as an engineer, everything's iterative, and we don't jump up and celebrate every time something happens. You kind of just like move on to the next thing."
Yeah.
It's like I made a joke with my team. It's just like it's not like we celebrate every time we close a commercial deal, right? Like it's a little bit different, that mentality. We just kind of move on. And they said, when do you know you had a good idea? And I kind of it kind of like, it took me a while, but my response was, when somebody says, why isn't everybody else doing it like this? And there's so many things that converge there. It's like, wow, it's obvious now that you see it. Wow, that's a really efficient, simple approach. Wow, that makes so much sense. Why isn't everybody doing it? And so whenever I hear someone say that, or make the comment like you just said, is this going to be the next trend? Absolutely. That's that moment when you think, okay, looking back, we did a good job here. Going back to your question, though, when we have a balanced system and we have something that's simpler, it moves a lot faster. And so, larger, design type wind events like a hurricane coming in, we can obviously prep for that. We can take the software strategy of stowing into the wind, against the wind. All those things can be considered ahead of time. But something like hail may happen a lot faster. And so being able to account for, let's have the right product. Does it tilt to the right angle, right? Because obviously you don't want the load to go into the glass of the tracker, of the angle of the tracker. Do you want it to be into the wind, against the wind? And then on top of that, we've also deployed software solutions where we're connected directly to national, if not global, weather software companies, where they're saying, hey, you have a scenario there. But then at the same time, we also have software. The software capabilities allow a local operator to trigger that stow. And for us to go into it in, seconds and not minutes or half an hour or something like that, that's very powerful. That's something that, you don't want a local operator to look out the window and hit a button and watch all the damage to happen because their system moves too slow. That's something that with our balanced system, we don't see because we can move so quickly.
Well, it's, I think for all the insurance people listening, I think you said a few things there that are key, right? There's some key capabilities, the integration with weather, the integration with your operations center that's also looking at weather, the ability on a software basis to sort of get ahead of these issues and get them to full stow. There's also some behavioral things, I think, there. Most of the time these events are associated with weather where the insulation is not very great. So you're not really losing much.
Yeah.
By going to a full stow and getting it safe.
Yeah, it's
right.
raining.
Yeah. So go ahead and get it there and save it. Don't hope for an extra ounce of power while taking a risk on a massive loss, right? And that I think that's something that people haven't quite gotten a hold of. I don't know what your thoughts are there.
I mean, you nailed it. It's not just the tracker component. It's, do you partner with the right solar panels? Do they have the right frame? Is the glass thickness appropriate? Is the treatment for the glass ready for a certain size of hail? And then the third component of that is the insurance company, right? And so, your insurance rate would be very different if you did not have safety belts, did not have airbag, anti-lock brakes, forward collision warning, alarm systems, right? These are all things that we're taking into consideration in building a product that not only physically has the highest angle, can deflect the to deflect the hail, but to also partner with the right panel companies with the right technology to sustain an impact, but then also prove to an insurance carrier to say, hey, we have the largest fleet, and I can show you through our software that somebody hit a trigger to go into hailstone. Okay, so what's my next activity? I'm going to call and alert that operator and say, hey, you just triggered this severe weather hail defense mode. Can we come out and fly drones? And that data is really powerful. And it's only something we could do right now because now everybody, now the insurance companies can go back and say, yes, the claims can be substantiated. We believe that Nextracker has a product that is better in the market, and so we can treat it differently with regards to the insurance premiums. And that's really powerful because again, it's not about the components, it's about our holistic solution that we can give to a customer.
That's valuable data, although I have to tell you, given the weather you're talking about, I'd keep some spare drones around because you may lose a few of them. Like literally, they may just be gone.
Yeah, that's a valid point. I'll send out an email.
Well, listen, so something else occurs to me while we're dealing with these environmental issues and we're moving into these newer markets that are more complex. Our growth in those markets is also shaping the demand curve itself. So we're shaping the demand curve, which we now need to really respond to that from a technology perspective, right? How do you deal with more complex demand curves, as they're sort of evolving as solar penetrates into these other markets
This
from a
is
technology
really
perspective?
this is really analogous to XTR. Okay, we created a problem for ourselves by saying we have to go flat on a naturally undulating terrain. And so all the engineering, all the material that we have to bring in is making up for that. Or going out there and saying, hey, I'm going to rotate around the tube and have an unbalanced tracker and put a lot more on the power electronics, motors, and controllers, right? The same discussion here is we've created a problem. We've gone out there and said, okay, dear developer, you have to spend a bunch of money and get permission from the utility to say, okay, how much can I put on the grid? And they're going to come back and picking a number. I'm going to give you 100 megawatts on this grid. And then we go out there and say, we're only going to do less than 30% of that because the sun rises and falls. And so our capacity factor is really low. We've now created our own problem. And so the solution lies within the power electronics there is how do we get that from our own industry hurting ourselves to creating policy and product around creating a larger capacity factor that is just not PV only, but including energy storage or whatever capabilities that you can put on that electric point of interconnect, right? And so
Yeah.
I see a tremendous amount of opportunity in this space. This is really exciting because at the end of the day, this is where you can go to a developer or the off-taker and say, here's our solution for delivering electrons to you when you need them versus, hey, when the sun's shine, we'll give you something. And I want to be much better solving that actively.
Do the trackers take a part in, I mean, I know that, I know what the curve of a tracker looks like versus a fixed tilt, right? Are there things you can do from a technology perspective to help to match just inherently outside of storage, to maybe offset some areas, but, get paid to offset, to help shape that? I mean, it's going to combine, like I'm spitballing here a little bit because this is a difficult problem, right?
It is, but I think the solution needs to come from more than just the tracker and the production side, right? We need to, when you look at it from a capacity factor of I'm picking a number 27% capacity factor, right? We're leaving so much on the table. Why aren't we participating, putting clean energy onto the grid an additional 70%, right?
Yeah.
And there's not much that you can kind of squeeze out from the tracker space. But the power electronics and all the technology is there. We just have to deploy it and make sure it's reliable.
Does the industry, and I'm talking about the broader energy industry, not just solar here as a whole, do our utilities, do our off-takers, do they sort of understand that? Are they moving that way? Or is this something that, has yet to, kind of completely ferment in the industry as an understanding?
It's a very broad spectrum. Okay. We have one thing that I'm excited about with at least our company is that we have customers who are participating in a volume commitment agreement. These customers are extremely strategic. They understand why we're doing certain things, and they say they're more of the mindset of everything's going to go terrain following, right? There's other customers where they're mostly focused on first cost, CapEx, and whatnot. That's not an enjoyable conversation, at least for me, right? Because it's like, hey, if you're just going to focus on that part, you're focusing on the cost of the tracker by this small percentage compared to somebody else's. But at the end of the day, you're leaving 70% capacity factor out there, right? That end of the spectrum is never going to get it, right? But the ones that do, we are working really closely with and really excited to address those issues. And it's, hopefully we'll have another interview in the future and you're going to say, hey, is this the direction? And I'll say, absolutely.
I love this. We haven't even finished this one, and I got another interview lined up. This is perfect. I'd love another opportunity to talk about more stuff.
I've been
This is
told
great.
that I think too far ahead sometimes.
Yeah, I get that too. It definitely happens, but somebody's got to have our head in the clouds while the rest of us keep their feet on the floor, right? Otherwise, who's creating the future?
Well, it's one of the most beautiful chemistries about this organization is that Dan has created a beautiful culture around the customer commercialization. And without that, or with that, I get the luxury to put my heads in the clouds and think a little bit further, right? So we can execute on current product, current commercial activity, and at the same time look a lot further. And at some point in time, the spectrum that I'm talking about, we have partners who come in and say, I see what you're doing. I know it's going to take some time. I'm right there with you. And then there's going to be other partners that we're going to need to see that in the industry for a little bit before we catch up and participate. That's okay.
Well, I'll tell you, the world is a better place when the Alex Oz of the world are allowed to dream, because from those dreams, that's the stuff of the future, right? That's the stuff of that defines where we're going. And I got to give you guys some credit because to enable that within an organization is both hard and a beautiful thing. So that's great.
It's amazing. There's 6 co-founders here, and we're all still here, and it's a top-down culture that we thrive to protect and continue. And I appreciate the kind words you just had.
Well, circling back a moment, before we sort of close out, I think we've covered quite a bit of ground here. The bottom line is sites have nuance, right? They have issues associated with them. That creates a massive amount of variability. And what we're ultimately talking about, in order to scale in the industry, we've got to somehow find a way to standardize against that variability. Talk to me about how you approach that dichotomy holistically.
Again, there's this really interesting balance of how do you wring out every last cost versus what's scalable, what are your atomic building blocks. And to be quite candid, we're actually reviewing those probably every single year. That it changes based on the industry needs and the price points, and obviously region too. But for us, I mean, like a lot of it kind of starts at the drive mechanism, right? So you have this unique drive mechanism. You have a self-powered module, self-powered controller, comms, slew gear, all those type of things don't really actually hold the module, right? So the smaller that increment can be and the longer the rows, the more cost effective it gets. And so we kind of think about it from that perspective. We've always been really good about, the first one to reach this length of a bay type of a thing, right? And we still see opportunity there to go even further, right? So those building blocks, those fundamental building blocks are really key to push, and then also share with our customers so that they know how to design with us and standardize with us as well.
So for your customers, for those developers who are looking to procure equipment and trying to lay these projects out and design them for value and for life, and for the owners who are looking to try to bring as much value out of the asset that they have purchased or built and purchased, how should they think about standardizing against variability? Because they're building these large portfolios. If every site is a snowflake, it makes it really hard to scale that from a owner or developer perspective. Like, what kind of key things should they think about when they're making decisions? And I know this is my end of the into the time curveball. So take a minute, like think about it, but like they're listening. So let's talk to them for a minute.
You want to lead with performance first, right? And so with True Capture, we're differentiating that we understand that nothing's flat and there's no perfect day. And so diffuse light conditions, row to row shading, we are able to model that. Okay. And so when we first started on this initiative, we said, okay, we've got these independently driven rows, right? Which is actually a smaller building block, which is awesome, right? It's not like we have to build one central block and then have all these linkages go out. That actually constricts flexibility and makes it harder for our partners to do something that's custom, right? We have these independent rows, we can change the sizes, it's a lot easier to deal with. But when we first came out with that, the discussion of what performance gains was really unclear. And we set out actually to build our own design tool, and it's called TrueSim internally. And so we're on TrueSim version 5 now, right? And so it's been many, many years of development, and we're the only company that I know of that can go out there and, dear customer, here's a product. And the customer says, okay, well, you got a lot of, exciting claims here. And said, okay, yeah, we've got this software. It's better than industry, whatever is out there. We developed it ourselves. Now I can model this production better. But then now we're going to hold your hand and work with you as a partner to build it. And then once it's built, we're going to be there as a partner for asset management. And I think we're the first company with True Capture to go out there and say, okay, now we have MNV on that. And over time, how does TrueSim get better? Well, it's because we're the only ones who have that cycle of model, build, and then do measurement and verification. So our tool is constantly getting better, right? There's a lot of tools out there that people say, oh, that's the industry standard. But is it good? You have no idea. It's just there. Nobody challenges it, right? We're the first to go out there and say, okay, I think we have over 17 gigs worth of True Capture and over 30 years worth of data that tells a story of, are we doing a good job or not a good job, right? And you can see the trends from us, right? The first models we did, some were high, some were low, and over time they get tighter and tighter, more accurate. And so being able to have our partners understand that first from a production standpoint is really powerful. And then that takes us into how do we get into the Nextracker ecosystem and design with them together for True Capture, for production. How do we do the layouts in a way where they're more flexible? So if I go on site and I have to change something last minute, do I get stuck with this linkage and a larger atomic core block? I think it's things that we've focused on quite a bit. And again, it's top-down cultural from Dan, where we have to listen to the customers. Sometimes we do exactly what they ask for, and sometimes we respond with what we think they need. Like a perfect example is this is a live activity right now where a customer says, hey, I wanted an executive dashboard. And I'm really proud because, most of the time you take an AutoCAD layout and you create bill of materials and then it goes away. You never touch it again, right? We have something that's called map view where we now take that file and it is exactly what the operator looks at. It's not lines of code or it's not lines of like, here's your SPC, it's exact actual site. Right. And you can see the performance, you can see on tilt, all these things through this operational view. And it's really powerful because that becomes a part of the commissioning process. The guy on site knows which network controller versus sub power controller versus what tracker that he's talking to. And these, to answer your question, we are working directly with enabling our partners and construction partners to leverage these tools to make it easier to install, to commission, and then long-term operate, because now we know the QR codes and everything for each part, and I can service them, create an RMA if you need another part, spares, whatever, that can be done all through our software tools.
So what I heard there, if I may summarize, because that was a lot of great information, but most of us aren't quite as quick as you, so we got, take it in bite sizes, is make sure that your partners are people that have that full cycle of learning mentality and viewpoint. and who are there from beginning to end through the life cycle, looking to learn and get better, so that each time you work on a site, you're getting better, your sites are getting better, and your partners are helping you get there. And you guys have a bunch of tools specifically to do that.
Yeah, let me try to summarize it one more time.
Sure.
We have this 3-stage, right? We model, we build, and then we do measurement and verification. Okay, so I'm really proud of TrueCapture because it's this we capture some of the energy that would have been lost if it was shading or diffuse light conditions, right?
Sure. Yeah.
But what's actually really exciting is that it's not framed like this within the company, but it's actually the best O&M and asset management tool, because we modeled it for you. And now I'm telling you, based on our weather stations, our med stations that we have on site, the radiance, cloud, whatever, did we meet what we promised you? That's really, really powerful, right? And so you can go out there and say, hey, dear customer, here's our expectation, and I want a dashboard. You can show a dashboard, but at the same time, you won't be able to go in there and give them a report that says this is exactly how you did it. And so when the customer says, I want an executive dashboard, that's one thing, and actually really easy to do, because you just draw a bunch of squares and then put some numbers next to it. That tells you what's happening right now. But our TrueCapture M&V report tells you, did we meet plan? Did we meet the model this last week, over a year ago? And what's causing it? Because we can now go in and see, is there issues from performance from a tracker row, a combiner box, the inverter? All these things are things that I don't see the industry doing, because we're uniquely in a position to have model, build, and M&V.
Got it. So model, build, and then M&V are like sort of constant information to follow up and show that you're hitting the targets that you're trying to hit, and where you can make improvements. That's immensely powerful.
Yeah, and I'm kind of embarrassed because I think I summarized something by talking more than when I originally talked.
That happens all the time. Well, look, we're about out of time here. Is there any last, final quick thoughts you want folks to think about?
Just from my perspective, I couldn't be more excited about this space. It's been an amazing journey. We spun out of Solaria. We were acquired by Flex within 18 months. And before year 10, we're on our own on NASDAQ. And the opportunities that it's brought for us to do so much more is just extremely exciting. And, the mountain patents that we're filing, the things that we're thinking about, how to create a better solution for this space versus a component. I just couldn't be more excited to come to work and crank on this every day.
Hey, doing something you love that also benefits everybody else sounds to me like a pretty good combo.
It's not bad.
Alex, thank you for your time today. Try to, I'm looking forward to doing another one with you, and let's see if we can get Shug on here too. But as far as this episode, this is a wrap, and what a great episode, what great information, and hopefully people will really get as much out of this as I did. Thank you. You are a power player in the industry. Nextracker is a power player in the industry, and it has been a real pleasure.
Michael, this is fun. Thank you.
All right.
Find summary thoughts on this topic and more insights into operating your clean energy assets at origisservices.com. Thank you for listening to this episode of Power Players by Origis, critical thinking to deliver the clean energy promise.